Hello, welcome back. Now in this video, we'll continue to another 3 unanswered questions, which is question 6, question 7, and question 9a. Let's continue. Question 6a. Arrange the following alkyl halide in order of increasing reactivity towards SN1. So as we know, SN1 we will discuss about the stability of carboxylic ion. Since tertiary carboxylic ion is the most stable, so means that the most tertiary haloalkane will be the most reactive towards SN1. So based on the structure given, and then the student try to draw out the structure. So A is secondary haloalkane, B is primary haloalkane, and C is tertiary haloalkane. So that's why the arrangement is BAC, correct? So you will get 1 mark. Okay, if let's say in the question they ask you to discuss about the SN1, we will discuss about the stability of cation, stability of carboxylic ion, while in SN2 we will discuss about the steric hindrance effect. Next, the question will ask us to discuss about why the compound that you state in the A is the most reactive toward SN1. So like just now we mentioned, we will discuss about the stability of carboxylic ion. So it will better, you have to mention the compound compound BAC. So compound C is tertiary alkyl halide, which will produce tertiary carboxylic ion, and tertiary carboxylic ion is the most stable, which favor to SN1. So for this question, you will get 2 marks. Continue with question C. The question C asks us to write the mechanism for the ethanolysis for the most reactive alkyl halide in A. So again, we are going to means that we want to write the mechanism for SN1. So ethanolysis, that means the alkyl halide react with ethanol, which is the CH3 CH2OH. So step 1, this is the tertiary haloalkane. So the bond between carbon and Cl will break down, and then the step is low with the red determining step, so that it will produce a tertiary carboxylic ion. So step 1 is correct. But for the step 2, we are not using the H2O, but we have to use the ethanol. But basically the mechanism that will quite similar with the hydrolysis, because the oxygen also have 2 lone pair electrons. So basically is one of the lone pair electron will go and attack the carboxylic ion. So once this happens, so one of the structure here will become CH2 CH3. Okay, so this is the for step 2. And again, step 3 also we need going to use the ethanol, so which is CH3 CH2OH. So one of the lone pair go and attack the hydrogen. So maybe here I change it to CH2 CH3. So once this happen, so this bond will bond to CH3 CH2OH, and then the side product will be CH3 CH2 OH plus OH2 plus. Okay, in this case, for the if the tertiary haloalkane react with KOH aqueous, okay, then the reactant will be the H2O. Okay, if the, because for this one, this is the as in general we know this one is the strong nucleophile. So but then because of KOH we are using the aqueous, so that means the quantity of H2O is quite much in this case. So that's why we are going to use H2O when the haloalkane react with the KOH or NaOH aqueous solution. But for the ethanol itself is a weak nucleophile, so it will assist its molecule. So that's why we can directly use the ethanol to undergo the mechanism. Okay, now let's continue with question 7. An alcohol C5H-O can form 3 optically active isomers H, J, and K. So let's check the structure given. So yes, this is this is optically this carbon is chiral carbon. Okay, but for the structure J that draw, this is not the compound with chiral carbon because this is CH3 and then this is another group CH3. So means that this is not the compound with the chiral carbon. And then for the structure K, so we look at here, similar case happen. This is the CH3 and this one also is the CH3. So compound K also is not a optically active isomer. Okay, then next we continue. When H is heated with concentrated H2SO4, it will form the alkene L. And then when undergo oxidation, will produce a mixture of carboxylic acid. So as we know, if undergo ozonolysis, we will break the structure into two parts, the alkene into two parts. So for both side will form carboxylic acid, then that will be the H, compound H. So now let's continue with here. Okay, if this is the H, when the H undergo dehydration, so in general, I think first they will remove this hydroxyl group, so will become carbocation ion, and this is the secondary carbocation ion. Okay, so if this is the case happen, so will not undergo rearrangement, because if you shift to the left hand side here, you will get secondary carbocation ion, but if you shift to the right hand side here, will become primary carbocation ion. So in this case, they will maintain as secondary carbocation ion and won't undergo any rearrangement. Okay, so then next we will proceed to the deprotonation. As just now we already removed the hydroxyl group, you can roughly imagine like this. And then now if you remove the H from the left hand side, so the double bond will form here. Okay, so this is the structure. But we have another option. We can remove the hydrogen from the right hand side. So if remove from the right hand side, then the double bond will appear at here. So this is the second structure. Okay, then in between these two structures, so we have to identify which one is the major product. So if we look at here, this one have one alkyl group, two alkyl group. Okay, so that means then the other one have only one alkyl group, but this alkyl group size is bigger. So when we, according to the SAGEF rules, we just look at the number of alkyl group without considering the size of the alkyl group. So therefore, this will be the structure L, and it is the major product. Okay, so for this major product, so we will undergo oxidation, not ozonolysis. So oxidation using KMnO4H+. So this alkene will break to two parts. Since here have the carbon have one hydrogen, so the part will become COOH. So another side also have one hydrogen, so will become COOH. So this is the structure, okay, that can form the compound with the mixture of carboxylic acid after undergo oxidation. Okay, next part, the question asks us to draw the structure H, J, K, and L. So you already done for H and L, and the geometrical isomer of L. So geometrical isomer basically is linked to cis-trans isomer. Okay, so when look at here, the cis, which is the hydrogen next to each other, so correct, and then the trans, the hydrogen opposite to each other, also correct. For these two isomer, one pair of isomer, you will get 1 mark. Okay, so basically you already get 3 marks for this question. So now we would like to do the structure J and also the K. So since we have the do this, so have 5 carbon, so we have another one, because as we know, hydroxyl group can be at the first carbon as suggested, but if the hydroxyl is at the first carbon, this one is not the chiral carbon, because this one have hydrogen and then here also have hydrogen. These two are the similar group. So one pentanol will not be the isomer that with optically active. So if the hydroxyl group attached to the second carbon, so I think here we already proved it. It is one of the isomer with chiral carbon. So next, then we will go to the still the longest carbon chain, 5 carbon, but this time the hydroxyl group will be at the third carbon. So as we draw at here, we also notice that this CH2, CH3, CH2, CH3, they are same group. So that means 3-pentanol also is not the isomer with chiral carbon. Then next we will shorten the carbon chain to 4. Okay, so if I put the OH over here, so this one will be CH2, and then this one is CH3, and then this one is H. CH2, CH3. So this is the chiral carbon because as one group is CH3, one group is hydrogen, another one group is CH2OH, and another group is CH2CH3. Okay, then next we will move the carbon. Still, sorry, we will not move the carbon. We still maintain the longest carbon chain as 4, and then the 5th carbon will add the second carbon. So and then the OH group will be here. So if this is the case happen, CH3, CH3. So I think this one is similar with the structure J. So we already know that structure J is not the isomer with chiral carbon. So we can skip to the next structure. So next structure will be the second carbon attached with the carbon, and then now I move the OH to here. So for this one again, we will get the structure CH3, H, OH, and isopropyl. So this is the chiral carbon. So these two structures, either one can be the J or either one can be the K. If this is the J, then the other one will be K. If this is the K, then the other one will be Okay, let's continue with last question. Question number 9a. R is the ester and then produced by the reaction of organic S, and also T with the formula C4H10O form cloudy solution instantly when react with the Lucas reagent. So then come out in our mind will be tertiary alcohol. So roughly we will have the idea, the S will be the carboxylic acid, and then the T is the tertiary alcohol, and then we'll produce R, which is the ester, so with the water as well. So the structure, the chemical formula of car ester is C11H14O, and then the formula for T is C4H10O. Okay, so what I normally, then we need to roughly know what is the chemical formula for the carboxylic acid. So what I'm trying to do at here will be that I will add on the H2O into the formula of R, which is 2 hydrogen and 1 oxygen. So end up I supposedly will get carbon 11, H16 and then O2. Okay, sorry, this one is O2, so that means this one will be O3 lah. Okay, then next I minus the carbon from the T and hydrogen, so minus 4 carbon, minus 10 hydrogen and minus 1 oxygen. So end up I left C7, H6 and also O2. So basically this will be the general formula for the carboxylic acid. Okay, then from here I can see that the student able to predict the compound T first, because as just now we say this one is the tertiary alcohol, and then only with 4 carbon, so that means we will get 2 methyl 2 propanol, so this structure is correct. But then when we look at here, the number of carbon for the S is more or equal than 6, and then the ratio of carbon towards hydrogen is almost 1:1. Normally when fulfill these two requirements, means that the compound will contain a benzene ring. Okay, so if you look at your friend's answer here, so the number of hydrogen 3, 5, 7, 9, 11, 13 and then 14. So that means number of hydrogen from S is already 14, which is not correct. Okay, so this is not the structure S. And then because of benzene ring already have 6 carbon, so now I minus the 6, that means I will have 1 carbon. Okay, so and then we know that this S is the carboxylic acid, so we know that this basically the structure of S will be the benzoic acid. Okay, so this is the structure of the S. Due to the structure of S is incorrect, so means that the structure of R also will not be correct. So the structure of R supposedly will be the benzene ring, and then for the carboxylic acid we will take out the OH, and then for the carbo alcohol we take out the O. So this one take out the H, so we will connect with the O, and then this O will bond to CH3, CH3, CH3. Okay, then the structure U is the S react with the ammonia to form U. Since U is the S is the carboxylic acid, and when the carboxylic acid react with the ammonia, which is NH3, so that's why I think we will get C double bond O minus NH4 plus. So acid and base, the formula for this one NH3, acid and base will form salt. So this is structure of U. Okay, so for each structure you will have 1 mark, and then next we'll write the equation for the formation of R. So basically I think for the equation we really focus on the reagent used in the esterification, which is concentrated H2SO4 and heat. Okay, so we always basically for the esterification we always use reversible error. Okay, so I think all the questions in the Bengkel Pecutan slot 1 are discussed. So I hope these 4 videos are helpful, and all the best in your PSPM. Thank you. See you again. Bye bye.